Algebra 2, Lesson 5.9, we're going to look at rationalizing the denominator. You can see our learning target is I can rationalize the denominator. The idea is that if we have a radical in the denominator, we're not going to consider that expression to be simplified. So what you hopefully remember from an earlier lesson is whenever you would have two of the same numbers inside of a square root, we would always circle them, say take one of them out and kill the circle. This would just be a 5. In other words, when you have two of the same radical, you'll just get the number inside of that radical. So we're going to use this idea very quickly to help us out. We're looking at this radical 5 down below, and we'll say, you know what? That's not what we want to see. That's not considered simplified. So we'll multiply the top and the bottom by radical 5. What do we get? 3 radical 5. And radical 5 times radical 5 is just a 5. Wonderfully, we are done. We take a look at example 2. And it's something very, very, very similar. We don't want to see that radical 2 in the denominator, so we multiply the top and the bottom by radical 2. By the way, the reason why we do that is we're really then multiplying by a 1. Radical 2 over radical 2 is a 1, and we won't change the value of that fraction then. We'll look up on top. We'd get 10 radical 2. Down below, root 2 and root 2, I've got two of the same radical. That's just a 2. But now, I hope you can see this problem is actually a little bit different. 10 divided by 2 can be reduced. And 10 divided by 2, you would say, is a 5. Your final answer is 5 radical 2. As we move on to, say, number 3, first off, we have a fraction 14 over 6, and tell you what, let's get our calculator out to reduce it. So we'll get our calculator out, and if we hit alpha y equals, we just go alpha y equals, we get our fraction, and then very quickly we can hit 14 all over 6. Now, 14 over 6, you might as well reduce this early. You'll get 7/3. And you, of course, could have reduced this much earlier, way before, even without a calculator. But look, if you have 7/3, that's the same thing as the square root of 7 divided by the square root of 3. And here we go again. We can't have a radical in this denominator, so what do we do? Well, we're going to multiply the top and the bottom by radical 3. The purpose thereof is to get two of the same radical down below. Radical 3 times radical 3 is just a 3. Whenever you have two radicals, they cancel out of the root. Radical 7 times radical 3, however, is the square root of 21. This is your final answer. You cannot reduce it any further. Then we're going to go to a second learning target. I can solve a quadratic equation by finding square roots. If there is an answer, there will be two. There'll be two answers. When you take a square root on both sides to solve, if you're going to take a square root on both sides here, there will be a plus and a minus. And that's finding both square roots, the positive and the negative. Now, the square root of 25, I hope we're well acquainted with that. That's a perfect square. Square root of 25 is a 5. So you'd have plus or minus 5. Now in ALEKS, you're going to separate your answers with commas. You'd have to say 5, comma, negative 5. Some of these problems will be perfect squares. They're going to work out quickly and easily. For example 5, when we take our square roots here, we'd get x is plus or minus a square root of negative 16. Now, please be aware that if you're taking the square root of a negative, that won't be a real number. There is no real number multiplied to itself that would equal negative 16. So you would say there are no real solutions here. If you're ever in doubt, let your calculator, let you see that you'd get an error by working that out. We have one last problem right here. For example, 6. We've got x squared is equal to 24. And if we took our square roots, if we did a plus minus, this is, in fact, very different. The 24 can be simplified inside of the square root. If you were to try to take the square root of 24, you'd get a decimal. That's not what they're asking for here. They don't want you to give a decimal answer. They want you to simplify it, to reduce it. So you might remember how we broke down square roots. We had our primes. We had 2, 3, 5, 7, 11. And we did a division tree. We'd say, well, is 24 divisible by 2? It is. You get a quotient of 12. Try 2 again. 12 divided by 2 is 6. I can divide by 2 one final time. Then I get 3, which is also a prime. So here's my little division tree. Also, some teachers call that the hockey stick. But it's 2 times 2 times 2. 3 2s times a 3. Well, how did we proceed with this? Well, we always looked for doubles, any pairs. And what we did is we said, whatever you circle, take one of those items out and then kill the circle. 2 times 3, you'd see, is just going to get you a 6. These two numbers aren't circled. So here are your 2 solutions. You would write 2 square root of 6 and negative 2 square root of 6 in Alex. And that is lesson 5.9.